Hi, everyone.
Hey, everybody.
Hey guys.
Hello.
Hi.
Thanks for joining.
Hi, Billy. I would say we give it like 2 or 3 more minutes. Still people are coming in, and then we can start.
Nice to hear you too, mate. So for everybody who's just joining, welcome. We'll be kicking off in a couple of minutes. This is our first time using this broadcasting technique, so please bear with us. So maybe while we're still waiting, Patrick, I think I might get us started a little. Just to introduce us, I think it might be a good idea to maybe have a few words. And maybe let's start off with something personal. Like, how did you get started with neuromore?
I got started with neuromore back in 2011, 2012. I have a background in computer science, software engineering, and back in the day I was more focused on computer security and highly scalable cloud system, while having a strong interest, it was still a hobby back in the day, in variables, biometrics, and things like that. So I guess it was around like end of 2012 that I got hands-on an emotive epoch. I bought myself one. And I was fascinated for the first day what can be done with the SDK that they provide. And yeah, after a day or so, I went online and I found all those papers being available, like all those like studies that are in the public domain, and saw a huge potential what can be done in the realm of neurofeedback and biofeedback. And I simply wanted to put those papers to work using the gear. I was like, now I have an EEG and I have that beautiful protocols written in a PDF or somewhere online. And now I just want to use it. And I didn't find an easy push button, easy way to get started. Like the first friction point was how to integrate the SDK into a tool, how to do FFT and so on. So it became quite a challenge. So I was searching for the software that enables me to easily do what I wanted to do. And I didn't found anything. So I ended up partnering up with the University of Stuttgart, their Institute of Human Computer Interaction. And yeah, we created the first prototype, the first version of the neuromore Studio, and that was available end of 2013. And early 2014, I decided to make it my life's work and yeah, quit my previous software job and focused on creating software for processing and the analysis of real-time biodata streams.
Amazing.
Andy, what about yourself? Andy is our CTO at neuromore. And Andy, why don't you drop a few words about your background, about yourself?
Okay, well, yeah, I came from a very similar background. I was actually kind of a biomedical engineer. So I did engineering as well, but it's quickly led to software as well, and then also building large systems and and things. But then a friend of mine one day, he came to me and he knew that I was a bit nerdy. So he's like, "Hey, my dad's just had a stroke, and he's finding it difficult to communicate. Is there anything you can do for him?" And at that time too, I was probably maybe about a year later, after you got started, Patrick. Yeah, I started playing with the Muse, and I started building art pieces with them, trying to work out if I could get some kind of control system working, that could be used to help my friend's dad basically get some function back after his stroke. And yeah, it did work, but the accuracy was like it was never good enough for me to give it to him before he passed away, unfortunately. But you know, it was it was kind of a wonderful experience. You know, I built this thing. It's, you know, like you could browse the internet very basically with it, but the accuracy was a little bit off. But I kind of did that by myself. And yeah, I felt like also, like, you know, I needed to do this not just by myself. I wanted to join a team, and then luckily we came across paths, and yeah, it's been wonderful ever since. Made some great software, and it's been a wonderful collaboration.
Yeah. Thanks, Andy. So yeah, I believe most of you haven't heard from us over the course of the, let's say, last 2.5 years. I know there are also some folks here in the room that we're still in close ongoing collaboration. Yeah, one of the reasons for that was that between late 2016 and mid of 2019, we were fully focused on supporting businesses and some researchers. And yeah, didn't really offer a lot to the community. And end of 2019, we decided we want to give it back to the community and open the technology up to everyone. So that leads to us open sourcing everything that we have, like the whole neuromore platform. We did it kind of like in a stealth mode. It was mid of November 2019 at the Transformative Technology Conference in Palo Alto. And even that we didn't do like any outreach to social media, email or marketing or something like that, we already got great feedback from lots of people. And we quickly realized that there's a growing demand in questions that are coming up in tutorials and stuff like that. So we decided to start a Q&A session, kind of like a recurring, ongoing Q&A session. So today is the kickoff of that series of sessions. And yeah, for today we want to cover what is neuromore, kind of like a high-level picture. Then we want to speak about open source and licensing, how to get hands-on, what it means. Then for today, we want to focus on the neuromore studio and focus on certain aspects of the studio. And after that, we want to do a Q&A session. We now have like 26 people in here. I think it's a beautiful number. So I try to keep it short, and yeah, so we have some room left for questions that might arise out of the next like 30 minutes or so. So what is neuromore? Neuromore consists out of like 3 major components. We have the neuromore studio, which is our graphical development environment. It's a beautiful user interface. We will have a close look at it later on. Then we have the neuromore cloud that can be used for user management, data storage, configuration management. And we have the neuromore engine. And the neuromore engine is where the magic happens, where all the calculations are being done. And the neuromore engine, like we can see, it's kind of like the player. So you can look at the neuromore studio as the production environment. Like in a music studio, if we look at music, then the neuromore studio is like the music studio where the artists sit and mix it. Then there's a cloud, and the engine enables mass distribution. So the engine can be seen as a Spotify player or Netflix player that enables billions of people to consume the experiences and applications that have been created in the neuromore studio. And despite a graphical development interface, neuromore studio is also a research tool that can be used just purely to conduct research. So really the core of the neuromore system is, we already talked about in the intro, that everything started with an emotive epoch. So we support EEG. As of today, we support a broad variety of EEG devices. So from a one-channel NeuroSky device, the Muse 2, the Emotive Insight, Emotive Epoch, all the way up to medical grade and even military grade devices. And over the course of the creation of our platform, we also added other modalities like ECG, EMG, respiration, and we have open sound control. We use open sound control as an open network protocol to stream data in. But now, us being open source, you can imagine that everyone can integrate whatever whatever is needed. And on the other hand, there are some outputs. There's some simple data visualizations. There's feedback visualizations. So with feedback visualizations, we talk about any kind of neurofeedback applications, biofeedback applications. We also have some pre-created games that can be connected to the neuromore studio. We can feed into any kind of API, to our own cloud API, but also to any kind of third-party API. And all the classified, analyzed data and all the metrics in those regards then can also be streamed out via OSC. So via OSC, we have a beautiful way to do real-time integration of distributed systems. So on the one hand, if you want to integrate in your own input device or your own output device, you could straight implement it into neuromore studio, and we can talk about it later, which would be that you implement your own node. Or what might be easier for you, if you already have an existing application for input or output, you can just make it talk OSC, and there's OSC libraries for like any programming language out there in the universe. And usually with a couple of lines of code, you can make your pre-existing application, either if it's an input or output stream, talk OSC, and by doing so, you can connect it to the neuromore platform. So open source and licensing. Open source.
Actually, I might just interrupt, Matt, and just say, like, considering that we are open source, and that there are more also technologies that I think people might want to connect with. Like, please do consider that if you end up writing an LSL plugin or your own connections to your own devices, and Patrick used the word node, which you'll see later on. But if you do connect anything to any of your own hardware or any of your own services, please consider like open sourcing it.
Yeah, that's a good point, Andy. Thanks for mentioning it. So yeah, if you want to get hands-on on the neuromore technology, including the neuromore studio, we have it open source. We have binaries and the source codes available. So you can just go to github.com/neuromore/studio or access it through the neuromore website. So you either go through neuromore.com, you click on downloads, and then you can create your cloud account. That's for free. And if you click here and download instructions, you will end up on our GitHub page, and you will see that there is 2 different ways how you can get hands on neuromore. You can either go to releases and download pre-built binaries, and we currently have binaries available for Windows. So there's a 64-bit binary, a 32-bit binary. What came new today is there's a Studio zip. It's a full package, and it's not just a Studio binary, it also includes 3 of our visualizations. So that can be used out of the box as a biofeedback, neurofeedback toolkit, play around with it. Then we have a macOS version. We have a binary for Ubuntu that should also run on Debian. And for the neuromore engine that I also mentioned, we have it as a binary, we have a JNI wrapper, and yeah, you can just download it here. And if you're more into like building it yourself, there's a pretty comprehensive step-by-step guide, what you need to do if you want to build it. And yeah, that should get you started. If there are any issues in regards to building or something like that, we encourage you to just open an issue here on our Git page. We will look at it like almost on a daily basis, comment it, and prioritize it accordingly. So talking about the license, so neuromore is dual license, which means we offer it on the one hand under a commercial license, and on the other hand under an open source license. So commercial licensing is on a per cases on request basis. So you can just drop us an email. If you go on the neuromore website, you go down on contact, just drop us a note here, say, hey, I want to do this, I want to do that. And then we will set up a call with you to figure out which of our components you need, what degree of professional services you need, what kind of a service level agreement maintenance you need, and so on. And on the other hand, there's the neuromore public license. So the neuromore public license that we created is, I called it HEPL-ish. So it's HEPL with an additional clause that non-commercial use is not allowed. So you're not allowed to get any monies out of it. And we also added a worst case scenario to that. So in case you don't want to reach out to us to negotiate another license that does not force you to publish your changes, etc., then still like the normal public license, kind of like it doesn't allow you to use it commercially, but if you violate that term, it states that you owe us a 15% revenue share. So we're aware that the 15% rev share might be a big number, so that additionally should encourage people to just reach out to get like a custom tailored commercial license. So we already talked about, or briefly talked about nodes and adding your own devices and things like that. And what we did, it's commonly known in the GPL world as a class pass exception, for instance. So we created a neuromore class exception, and that allows you to implement your own nodes and the additional nodes that you create. So we distinguish between if you change our core system, something in those regards, and you're under the public license, you also have to share all the changes that you made. But if you have your own device and you want to create your own input node, and then you want to create your own machine learning node, then those nodes are accepted, they're excluded from the normal public license, and you can choose to license them under whatever terms you envision and you want. And yeah, like Andy already said, we of course encourage you also to give back to the community, and maybe you'll even want to choose a similar license or a similar model that we did. All right, then there is the neuromore Studio. So we already talked about how to get the studio, you go on GitHub, you download the releases, or you can build it yourself, or you can do both. You want to do this. So let me change screens. All right, here we are. So assuming you just got the neuromore one file binary, that's what I have here. Then you open it, and that's the first thing that you will see after you logged in. To log in, you simply go, if you do not have credentials, there's a link on the sign in form, and alternatively, you can go to neuromore.com. And on neuromore.com, you can choose to create your own cloud account. You click on here, you do that, and within less than a minute, you have your own neuromore cloud account set up, and that cloud account is required to log into to open neuromore Studio. So what we see here, yeah.
Sorry, maybe just to interrupt. I think people are probably wondering, like, what, you know, if it's absolutely required that we have the neuromore cloud going. And I think I just wanted to say that the engine underneath actually runs on devices themselves. So I think how we're different from maybe some other software that's on the market that might be similar to ours is that if you get the engine on your phone, it runs on the phone, and so connecting to the cloud is really just about downloading the configuration, and Patrick will basically discuss and show you what that will mean in a second. But I kind of wanted to really just to impress the fact that, you know, we are, all of our stuff is running super fast on device. It doesn't rely on the cloud. It doesn't have to rely on the cloud. So yeah, I just wanted to get that out there. So if you're thinking, oh, you know, we need to be dependent on some you know, like internet or something out there, that's not the case.
Very good point, Andy. So yes, the neuromore Studio itself only uses the cloud to authenticate the user, to pull the configuration, and for file management. But now neuromore Studio being open source, I can envision that if someone really wants to run everything locally, it shouldn't take that long to create an offline branch of neuromore Studio, for instance. So, and as Andy mentioned, like all the magic, all the processing happens locally. So we only use it, as we can see here, as a backend file system to store all the configurations. But none of your
really
data.
Important for, sorry, I was just gonna say that's really important for data privacy. So like in terms of GDPR, I think one thing that might separate us also from our competitors is that, yeah, like things don't have to touch the cloud. So medical data doesn't have to touch the cloud necessarily.
Yeah.
You know, all of that stuff can run on device, and then you can be very fine-grained about what privacy information you share or you save. And so and we kind of leave that up to you.
Yeah, good point. So the neuromore Studio itself consists of different windows, so you can move them around. You're pretty flexible with what you do. So what we see here is just the layout. See, it appears the default layout. There's different layouts that we pre-built, but feel totally free to create your own layout. You can close windows, you can move them around, you can move them to another screen, you can have multiple screens, and so on. In case that you close one of those windows and you're like, oh, I want it back, you go in view, and then you can add and say, oh, there's the devices window, we just bring it back. And it's a pretty neat system that can be used for the windows and the controls that we already created. But it also enables you to easily create your own window, your own control, whatever you want to see in the neuromore Studio that's currently not there. All right, so what's important is the backend file system. And like the Windows sits, it sits in the cloud. So we have three different types of items of files to say that are being stored in the backend cloud systems and that are part of a neuromore experience. So we have a classifier, we have a state machine, and we have a design. For today, for the intro, we will only talk about the classifier, but for upcoming sessions, we will also dive into the state machine, the design, and how the state machine and the classifier can interact with each other to create a fully interactive biodata-driven user experience app or something like that. So a high-level description of those three things is the classifier, as we look into it in a minute, is the data classification. So some data in, classify it, do some operations on it, and output the result of your classification of your algorithm or whatever it is.
Yeah, it's really about signal processing, isn't it, Patrick?
Yeah, exactly.
Yeah.
Just signal processing. The state machine itself is not about signal processing at all. It's about interactive storylines. What happens to the user? What message do we show the user at what point in time? And the state machine can be informed by the classifier. And the design is basically a combination of a state machine and a classifier. So in that backend file system on the side, you see there's that folder with that long number. That's my long UUID for that account that I created just for today's meeting. So that's your personal space. Whatever you create in here just belongs to you and is yours. And down here, you see that we also have some examples that are ready to be looked in. So you cannot create any files down here in those examples. So if you want to create a new classifier, you just do that in your user folder. We call it Patrick's classifier. And then we can open it. So one neat thing about that backend file system is that we do versioning with all those files. So it's like with GitHub, like a source code versioning repository. We also do that with all the revisions that you do. You also can create folders in here, and yeah, I guess for the sake of today, that's sufficient. So once you open it, you see that that particular classifier window now shows Patrick's classifier. And now we can get started. I'll just remove that for now. We don't need that, and we also remove that. So within the classifier, we have different tab panels for different nodes. So we already mentioned the term node earlier. So if I drag that in as a test system, so that's a node. Node name, test system. We have different input nodes that are already there. We have the test system. It just randomly generates EEG data that can be used. And we also have a Muse node in that particular version. We have an OpenBCI node and a heart rate node. I saw in the chat that the question is if the Muse 2 will ever be supported. The good news is that based on our open sourcing, someone else already integrated the Muse 2. So if you go on our GitHub page and you go all to the end, you see that beautiful project from someone else run the Muse 2 in neuromore. So just go there, and also the Muse 2 will be integrated as of today. Despite those devices that we have here, we also have more devices available. And if you're interested in looking into what devices are currently supported, you can go to the wiki. And we created an overview, which devices, which models are supported on which operating system. And the list is constantly growing. If there's a device that is not integrated, you can either integrate it yourself or open an issue here and ask the community and us to integrate your device.
I just probably want to speak to that too a little bit more, in that some of the licenses that we've integrated with some of our technical partners, or like the guys who provide the physical devices, don't allow us to share that open source. And so if you do, or if you are interested in a particular device, yeah, please contact us, because we might already have it. It's just that we may not be able to share it as well. And that might also be a point to ask. Please ask your vendors of your products that you're using, if they're not integrated with Neuromore Studio, please ask them, because I think that'd be really helpful for everyone. I think if we all went open source, so yeah, please help us.
Yeah, that's a great point. There was actually one of the pushbacks that we received, that quite some of the device manufacturers kept us from shipping their drivers, their libraries integrated into our binary. But as of now, you can just get the open source version. The build system is pretty solid, and it's kind of like a gold standard thing, like in terms of tool what we use. So with a little effort, you can just get whatever, like emotive SDK, for instance, and then just build your own version with it.
But if you do want help with that too, we do have internal work that's already been done on that. So please do contact us.
Yeah, no, absolutely. Like for instance, like speaking about the emotive, it's literally the only step that is required for the community to get emotive support into the Neuromore Studio is to use our source codes. You download the library from their website, you place it in a folder, you press build, and you're all set. So that's the only missing piece, and that's the only part that is being restricted by some of the manufacturers, that we are not allowed to pre-build it and ship their libraries together with the studio. All right, coming back to the nodes. So we have a bunch of sensor input nodes. We have a parameter, which can be kind of like a static value. You can have a signal generator. We talked about OSC. So you can stream in OSC data. Within the node, you specify the particular address. Most of those nodes also have a sampling rate attached. And in regards to the OSC node, here on the network, you can configure the port, like the endpoints and so on. So there's also in doc.neuromore.com, there's a little tutorial about how to set up OSC with the Neuromore Studio and like other devices. So those are some of the input nodes. There's also a file reader, so you can read in comma-separated files, EDF files. Feel free to extend it to a file format that you want to see and don't see yet. We have a cloud input, which is a nice way, because all those classifiers can write data to our cloud if you expressively want to do that. And you can store data on a user level or on a classifier level, and then can make those classifiers kind of like, yeah, stateful to a certain extent. So you can kind of like start initializing a classifier with the last state that it has been left. And then there's some output nodes, because that classifier is all about getting some data streams in and then getting them out. So we have custom feedback. Custom feedback means those values are being transmitted to our visualizations, and those values can also be seen here. All right. Change it over. Yeah, that's better here. So we have that custom feedback now. If you add multiple, you see that those custom feedback nodes all show up. If you rename those, it just changes automatically on demand. For those custom feedback nodes, you can choose an OSC address to transmit. You can choose to upload the data to our cloud, like that flag is not checked by default. So if you check that, that means if you run a session with that classifier, the value of that particular node will be transmitted to our cloud. But if you look into our data privacy terms in our policy, we clearly state that all your data belongs to you. So it's not part of our business to monetize or sell your data in any way, to also make that crystal clear here. So it's just a service that we offer to you that you can conveniently store your data, period, if you want to. Then we have a cloud upload as well. You can store certain parameters, you can store it to a classifier, you can write to a file, and you can view certain things, which is more like a debugging thing. For instance, if I take the test system and I feed it in, now I see here in the signal view, like everything that I just connected to the view node. And I can add that signal generator, and then it also shows up and so on. That's a pretty neat tool for you to debug what you're currently doing in your processing pipeline. So, and in between those input and output nodes, most likely you want to do some modification, some calculation. Otherwise, the neuromore Studio would only be helpful for you to do some resampling, to data correlation, and so on. All right, then in terms of operations that can be done, so we have mathematical nodes. We have a mathematical function, sine, cosine, whatever. It's kind of like all the mathematical functions that we came across so far and that have been needed. There's some simple mathematical operations. There's comparisons that can be done. There's logical functions. There's some remapping. You can do some channel mathematics, sum up two channels. You can do statistics, and you can do an integral with some of those things. So that's still all pretty standard. And if we now come down to where things get really interested, if we talk about biodata or EEG, then there's things like an FFT, you know, like a fast Fourier transformation, some filterings, can extract frequency bands. And the beauty of that system is you can just go ahead and you connect those things, and then you can say, oh, let me look at that spectrum. And then you would need a spectrum for you. Okay, let me get that up for you. Yeah, and now we can look at the spectrum that we just had here. So let me drop that over here. And now we're looking at all those spectrums. So I can say, oh, what happens if I change the FFT order? And so on. So that's pretty neat. And the beauty of that visual programming is that it's very simple on the one hand, but under the hood, like all those operations, no matter if it's the FFT, any kind of filter, or any mathematical operation, is being done by the neuromore system and by the neuromore engine, and the neuromore engine is being initialized with that classifier. So it runs highly optimized, like Andy said, on device. And every moment that you do whatever changes in that classifier, like the neuromore engine automatically gets updated. So what's also neat, if you try to connect things that do not make sense, kind of like a spectrum output with a non-spectrum input, then it just doesn't work. So yeah, I don't want to say like test it out, but it should be incredibly hard to create classifiers that do not work, at least from a node perspective. So now we can feed it in here to the frequency band, for instance. So let's remove that connection. Now we can look at, how does it look like now? Now we have all the frequency bands extracted. So yeah, if that FST order is nicer. Yeah, the test system is just randomly generated data, so it's not my brain currently that goes bananas. Just for the simplicity of showcasing that. So now we have frequency output, for instance. Now we can look at the dominant frequency. We connect that. Hold on, doesn't work. We need the frequency band. Let's do that. Yeah, we also need the spectrum here. There you can look dominant frequency, for instance. We can say, oh, what's the dominant alpha? You can choose what alpha means to you. Then you can output that value again to whatever custom node. So that particular node now would be dominant alpha. And the node says, oh, value not in range, you know? So we said that the output is range between 0 and 1, which is not the case. So we just remove it. Now the classifier is happy again. We just received. All right, yeah, we will cover the engine later on. And it's also a nice question, is there a function to show coherence? So as of now, we do not have a coherence node, but that's definitely something that would be a great addition to the current library of nodes. So feel free to open a Git issue and requesting it, or if you're a programmer, create it yourself. And another question, will you give us an overview of the devices the engine will run on and any limitations? So the engine by itself, like the Neuromore Studio, has been created in C++. Neuromore Studio also some C#, I believe, but the engine is plain C++. So we successfully ported the engine to different mobile devices. We ported it to a head unit of a car. It runs on a Raspberry Pi. We saw it running on an Xbox. So Andy, maybe you can jump in, but I don't see any reasons that with some effort it should run on like every devices that can run software.
Yeah, I think, yeah, no, to be honest, like it should run everywhere. We've got it running on you know, handheld smart devices, you know, laptops, phones, iPads, all of the things. So I could imagine that you could also run it also on, you know, real-time operating systems and chips, and run it on your own chips, all those kinds of things. So yeah, but if you do get into any trouble, just let us know.
Yeah. In terms of, yeah, just let us know. So there's of course two ways of engaging with us. On the one hand, there's the community side. On the other hand, like I mentioned already, we also offer professional services, and we can also build something for you. We can maintain it and so on. So that's important to know. And most of the times we see some hybrid versions of that, where we do an initial workshop, we get a client's team started, and then try to phase us out down to second level, third level support, and yeah, helping out with more complex topics or new features or whatever it might be.